We'll proceed in vector algebra and calculus. Vector algebra and calculus, we are pursuing discussion on vector and then algebraic vector and then how we can do calculus on algebraic vector. So that is the scenario that we are pursuing. Now in that case, we are in a phase of calculating surface area of a sphere. One is through primitive calculus, one is through a new approach, new modern calculus. Now we will try through the velocity vector, acceleration vector, displacement vector. That is the idea. Okay, I believe it's all right. So how to calculate the surface area of a vector, of a sphere? Okay, I have a sphere. How to calculate surface area of a sphere? If I want to calculate surface area of a sphere, if I want to calculate surface area of a sphere, then one way how we calculate a curve length of a curve. If this is the curve, then how we calculated curve length? To calculate the curve length, now consider this is x-axis. If this is x-axis, this is x-axis, this is y-axis. This is a circle and its equation is x square plus y square equal to a square. This is a sphere and equation is x square plus y square plus z square equal to a square. If it is this is a circle. Okay, if this is a circle and its equation is a square x square plus y square equal to a square, means y equal to square root of a square minus x square. Y is dependent upon x. This proves, right? Y equal to square root of a square minus x square. Y is dependent upon x. Y is also called function over x. What is function over x? That is square root of a square minus x square. If I consider a sphere, then z is function over x and y because z equal to square root of a square minus x square minus y square. This way, z is dependent upon x and y. I can say z is function over x and y. Z equal to f, small f bracket x comma y. Function over x and y. If that is the scenario, then how we found the curve length? Now, if I take any point x comma y, this is typically called displacement vector or kind of position vector. P. P is xi plus yj. Xi plus yj. If I differentiate it, then xi plus yj. X is x component and y is y component. Okay, xi plus yj. If this is a position vector, then dp by dx, if p represents the point on the curve, dp by dx is called velocity vector. Okay, so if p is position vector, then dp by dx is called velocity vector, where p talks about the curve, where point on the curve is x comma y. dp by dx is velocity vector. Okay, if it is velocity vector, the magnitude of dp by dx is velocity magnitude. If I integrate it back with dx, it gives me displacement magnitude. If this point is the displacement point, displacement magnitude over a region would give the curve length. Oh, oh, oh. This is the fundamental, that is through velocity vector, acceleration vector. This is the relationship between differentiation and integration, right? If I have a distance and if I derive the distance with the time, it becomes velocity. If I have a velocity and if I derive velocity by time, it becomes acceleration. If I integrate acceleration with the time, it becomes velocity. If I integrate velocity with the time, then it becomes displacement. So if I say dp by dx, then it becomes, this is a vector. If p is a vector, dp by dx again is a vector. If dp by dx is a vector, if dp by dx is a vector, if dp by dx is a vector, then the the then this is called, then dp by dx is called velocity vector. dp by dx is called velocity vector. Now if I integrate the velocity vector, then I'll get back that p back. dp by dx integration is p back. I don't want p is a vector. I want curve length. So dp by dx, if I do velocity vector, if I calculate the magnitude of the velocity vector, why we are doing like so? Why can't I calculate the magnitude of, when magnitude of the position vector itself? Someone would say, right? If you have a position vector and you are saying it is displacement, calculate the magnitude out there only. Why you are saying dp by dx and then calculate the magnitude, then integrate it back, you will get the curve length. P vector, P vector, the P vector is this. If I calculate magnitude, it will give me the length of this vector. This is not I want. I want length of this. So dp by dx, the velocity vector is along the curve. It is not along the line. That is the catch here. So catch is dp by dx is velocity vector. That is true. But velocity vector direction is along the curve, not orthogonal to the curve. This is what the position vector is. Now for that, if I calculate the magnitude, then it is something that deal with the curve. But anyway, it is velocity, not the displacement. Now if I integrate, I get the length along the curve. Makes sense, right? This is enjoyment with a vector. Vector has magnitude and direction. So where is the direction? If you calculate the magnitude, things will come in that direction. If this is position vector, dp by dx is this, tangent. This is along the curve. This is also called curve vector. But this is velocity, not the displacement. So I have to integrate it back, calculate the magnitude and integrate it back, then it will give the length because it is along the curve. If I get any vector that is along the curve, then no need to go for the, no need to go for the differentiation at all. Makes sense, right? If then someone would say, then why don't you find a vector along the curve? Why you are going with position vector and differentiation? Certain, if someone is finding a vector along the curve, but then it will be algebraic vector because every point the curve vector is different. So a tangential, this vector is in this direction, here vector is. If someone is able to find the algebraic vector at any moment x can comma y, certainly he can calculate the magnitude and he can get the curve length. Or someone can say this is one of the way to find the algebraic curve vector, that is dp by dx. dp by dx. Okay, now I believe we have done it. Now I have similarly, this is centered at the origin. The center of this, not guava, center of, this is a guava and it's very big. It is around half kilogram easily. Okay, now consider that this is centered at the origin. This is centered at the origin. This is a sphere centered at the origin. If I take any point P here, any point P here, what would be the point P? X, comma, Y, comma, Z, where Z is dependent upon X and Y. Independent component is X axis, Y axis. This is X axis, this is Y axis, this is Z axis, this is XY plane. This is XY plane, that is independent. X is independent of Y and Y is independent of X. But height, that is Z, is dependent upon X and Y. How they are related? Z equal to square root of A square minus X square minus Y square. Now we will use same concept to find the surface area. Now what is dp by dx? What is dp by dx? P is xi plus yj plus zk. dp by dx velocity vector along x-axis. Velocity vector along x-axis I xi plus yj plus zk, that dp by dx is I plus dz by dxk. dp by dy is j plus dz by dyk. Makes sense, right? Okay, these are two partial derivatives. So, but they land up in vector form. Partial derivative, they land up in the vector form only. Now, if this is the position vector, if this is the position vector, means this is the position vector. This is the position vector. Then if I cut like this in xz plane and cut like this in yz plane, then dp by dx, if I see mathematically also, then dp by dx is I plus dz by dx k. dp by dx, if if I go along x-axis, if I take any point P and this is x-axis, then dp by dx means its derivative along x-axis. Now this point P has, if I go down on x-axis, there is a point called x, because this point is x comma y comma z. If this is x-axis here, if I come down, there is a point called x here. If I move 1 unit along the x, then how much position vector P is changing? dp by dx. If I move along y-axis 1 unit at point y, how much position vector would change? dp by dy. dp by dx is a vector itself, I plus dz by dx k. It's a vector which has component as I and k. There is no j component. So this vector would move in xz plane. dp by dy is another vector that would move in yz plane. So at this moment, if I say dp by dx, if this is the position vector, if this is from center of this to p, there is a position vector, then dp by dx is tangential in xz plane. dp by dy is tangential in yz plane. dp by dx, dp by dy. If I cut it in xz plane, then it will make a circle. If this is P, then this is dp by dx in xz plane. If this is the P, if I rotate like this, then dp by dy is a vector, this is a vector in yz plane. This is a vector in xz plane. dp by dx, dp by dx, dp by dx, dp by dy, dp by dy. So dp by dx, if I say like this, then it is I only when x is 0. Okay, at that moment dz by dx. So if I see the top maximum at that moment, this is z, this is x. Here dz by dx is 0, this is maxima. In that case, dp by dx is I only. Certainly, it is I only. dp by dy here in yz plane, it is j only, because dz by dy is 0. Now, if I have dp by dx, if I have dp by dy, if I have dp by dx, and if I have dp by dy, what is the surface area at point P? dp by dx cross dp by dy. These two vectors, if I make cross product, one in yz plane, one in xz plane, if I make cross product, it gives me the area underneath. So momentary area at any point P, momentary area at any point P is dp by dx cross dp by dy. Okay, now I have to, this is the momentary surface area. If we calculated the curve length, if there was a circle and calculated a curve length, the dp by dx was velocity vector. That was along the curve. It is along the curve, then I calculated the magnitude, and since it is a velocity magnitude, I integrated with dx, I got the curve length. Similarly, if I do at any point P, if I have dp by dx in xz plane, and if I have dp by dy in yz plane, if I do cross product of these two, it will give me another vector. That vector is called, if dp by dx is velocity vector, partial derivative along x-axis. dp by dy is velocity vector, partial derivative along y-axis. dp by dx cross dp by dy is nothing but velocity surface vector. Velocity surface vector. What is velocity surface vector? Velocity surface vector is tangential surface that is tangential at any point. Any point you take that the dp by dx cross dp by dy will be tangent at that point. So here dp by dx is like this, dp by dx cross dp by dy is like this, dp by dx cross dp by dy is like this, like this, like this everywhere. This is called surface vector, and for this surface vector, this is the direction of the surface vector, perpendicular to this is the surface vector here, then this is the surface vector direction. If this is the surface vector plane, this is the surface vector direction. Vector, this is the surface vector plane. So surface vector direction is like this. Okay, that is better way. Surface vector area is like this. Its direction is like this in k direction. I mean whatever it comes. So now I have surface velocity vector. Rather than I would say dp by dx cross dp by dy surface vector, surface velocity vector. If I calculate cross product of it, dp by dx cross dp by dy, cross product of it, and calculate its magnitude, then if I integrate with the xy plane, okay, if this is the sphere and this is the surface we are thinking, okay, this is xy plane. So dp by dx cross dp by dy, where here denominator is x, denominator is y, means this is a velocity vector that is differentiated by x and y, dp by dx cross dp by dy. Or I would say the position vector p is differentiated along x-axis, along x-axis. Okay, if that is the along the xy plane. Now I have to integrate with the dxy plane to get the actual displacement or actual surface area. So dp by dx cross dp by dy, and then calculate the magnitude, that is the velocity magnitude, integrate with dxy plane, you get the net surface area. Net surface area. So dp by dx cross dp by dy is also called the surface area by dxy plane, or it is also called surface area velocity vector. If I calculate the magnitude, this is surface area velocity. If I integrate with dxy plane or dx dy, it will become the surface area, surface displacement area. This is what we want. Integrate along the x-axis and y-axis. So if this is centered, if this is centered at the origin, if this is centered at the origin, then x and y, if I take the snapshot on xy plane, that limit is a circle. So x is minus a to a and y is minus square root of a square minus x square to square root of a square minus x square. X is minus a, this is there is a circle here. Then x is minus a to a and y is looks like minus a to a, but for circle it cannot be independent. So y is minus square root of a square minus x square to minus 2 plus square root of a minus x square. dp by dx cross dp by dy magnitude someone has to calculate dx dy. Is it not coming similar to what we have already calculated? Certainly, because the result is same, right? So at the end, with different approaches, we will come to the same point. Now anyone can calculate. P is xi plus yj, xi plus yj plus zk, dp by dx is I plus dz by dx k, dp by dy is j plus dz by dyk. Cross product will come as minus dz by dxi minus dz by dyj plus k. Its magnitude will come as dz by dx whole square plus dz by dy whole square plus 1 square root dx dy. Now z equal to square root of a square minus x square minus y square. Full, if I settle it down, square root of dz by dx whole square plus dz by dy whole square plus 1, then it will come as a by square root of a square minus x square minus y square dx dy, and then integration minus a to a and y is minus square root of a square minus x square to square root of a square minus x square. Now dy, if I settle it down, many times I have kind of, means it is repeating. Now if I take y equal to a square root of a square minus x square cos theta, then dy equal to square root of a square minus x square minus sine theta d theta. Then it will settle down as a by square root of a square minus x square minus y square. Y, if I replace with a square, square root of a square minus x square cos theta, now whole term will become a by square root of a square minus x square into sine theta. Top is top is square root of a square minus x square minus sine theta d theta. Full will go away, minus a would remain there. Minus a I can keep outside. Now x is minus a to a, y is minus a square root of a square minus x square to square root of a square minus x square. D theta dx. Now d theta integration is theta. Now theta here y is y I have to settle down to changing it to theta, or I'll theta what has come as integration, I'll change it back to the y. So y equal to square root of a square minus x square cos theta. Theta equal to cos inverse y by square root of a square minus x square. Okay, so net integration is cos inverse y by square root of a square minus x square. That is the integration. Now lower upper limit, first I have to set. The upper limit is square root of a square minus x square. If I settle it down, it becomes cos inverse 1. It becomes cos inverse 1. Then cos inverse of 1, that is 0. And minus square root of a square, cos inverse minus 1, that is pi. So it becomes minus pi. Minus a is already outside, it becomes pi a. Now x integration, dx integration x minus a to a, 2 pi. So 2 pi. Okay, so outside there it is pi a, and here, sorry, x is minus a to a, it becomes 2a. It becomes 2 pi a square. And this we have taken x and y considering that it is the sphere is centered at the origin. If it is centered at the origin, then x and y, if you are taking, it is calculation in the top hemisphere only, not the bottom hemisphere. Multiply by 2, the surface area of a sphere is 4 pi a square. Is there any other way that we can try calculating the surface area? Through this velocity vector only. So velocity vector is the third region where we are calculating the surface area in vector terminology. I would say that in-depth understanding is good if I go for primitive calculus and modern way in the calculus. But velocity vector, acceleration vector, it is quick way to find out the stuff. Can there be another way? Can I consider a spherical coordinate system? Now we are going through Cartesian coordinate system where we have dp by dx cross dp by dy, magnitude dx dy, or I would say dp by d surface area by dxy plane, d surface area by dxy plane, magnitude into dxy plane. Can I introduce d theta now to calculate the surface area through spherical coordinates? So there is a spherical coordinate system. In a spherical coordinate system, there from center there is a line and touch the peripheral surface, that is called radius. This is one component. Other component is from the vertical, there is an angle called phi. If this is radius, then from vertical it makes an angle called phi. This phi is another component of the spherical coordinate system. Now, if this radius, if I take this radius, this is centered at the origin. If at any moment from the vertical, this is the radius right now. Radius means, okay, okay, this is centered at the origin. This is centered at the origin, at the half xy plane is cutting it. From center, imagine there is a point P here. Point P here. Okay, not top little bit in between. There is a point from center. If I draw a line from center, if I draw a line, then this is the point P here. Okay, if that is the case, if from center if I draw a line and this is the point P, if that is the case, then this P point and center there is a line connecting that is called A. That is the radius of this sphere. A, and that is the radius of this sphere. Then A sine phi. A sine phi. So if this is okay, if this is the vertical and this is the origin and this is the top point, then this is radius A of the sphere, and this is phi angle, and this is at up, and this is the radius at phi angle. This is the condition of the radius. This is phi. So A sine phi will be this line, this line, this line. This is if this is the sphere, then it is like cutting a slice at this point. If I cut, if this is the sphere, if this is the sphere, then I can, this is xy plane at the center, then at this is the point P, and from center if I draw a line that is the radius A making phi angle from the vertical, at this point if I make a slice, then there will be a small circle will come out there. For that small circle radius is R, that R is A sine phi. Okay, A sine phi. But this radius R, we are now taking the different component. Now this is the, if I cut it, there is a small circle here. Okay, if phi is 90 degree, then there is a big circle here. Small circle, small circle, small circle, and there is no circle. So at phi angle, it will make a circle. And on that circle, I can move 2 pi angle. That is theta. So there are three components in spherical coordinate system. One is radius A, one is angle from vertical phi, and at any moment if I cut it and it forms a circle, that is radius is R, then that angle is called theta, that rotates 2 pi, whereas this phi rotates from 0 to pi 1. Okay, these are the three components of the sphere. So if this is the radius and make phi angle and this is the R, what is x component? If I rotate it like this, then I rotated theta degree, I rotated theta degree. Phi is same. This is the phi, it is same. But I am rotating the theta. At any moment, x component is A sine phi, that is R, and angle theta, R, A sine phi cos theta. Y component, so if this is a sphere, where is x-axis and y? This is centered at the origin. At the middle, this is xy plane that is cutting it. So this is x-axis, this is y-axis, this is z-axis. Now any moment, A sine phi cos theta is x-axis, A sine phi sine theta is y-axis, and A cos phi is z-axis. If that is the case, now we calculated surface area with dp by dx. So what is the surface area? Which component will? So if I calculate surface area, radius is always A. Radius is not varying. Theta and phi is varying. So for the xy, that is variable here in Cartesian coordinate system, here theta and phi are variable. In that sense, now we have dp by dx cross dp by dy, or d surface area by dxy plane, magnitude into dxy plane. That I can rewrite whatever we have written into d theta phi by d theta phi. Now if I consider dxy, I can cut it down. dxy, I can cut it down. Now it becomes, and bring that d theta r, d theta phi inside it. Same thing. Now if that is the case, then someone would say this was the magnitude and dx dy was the integration. You can keep dx dy inside also. There is no problem in that. Because if you calculate magnitude, then anyway square root and square plus square plus square root dx dy will come out automatically. So you can keep inside. There is no harm in that. Someone would say d surface area by dxy plane into dxy plane magnitude. That is the net surface area. Inside the magnitude, I can again multiply it by d theta r by d theta r. dxy by dxy gone. Now it became d surface area by d theta r magnitude into d theta r. D theta r can be written as d theta dr. Now d surface area by d theta r can be written as dp by d theta cross dp by d theta phi. xy equivalent is theta phi. Now dp by d theta cross dp by d phi. Magnitude d theta d phi will be the surface area where phi is from 0 to pi and theta is 0 to 2 pi. Now someone can take it. What is p vector, position vector? Xi plus yj plus zk. X is a sine phi cos theta I plus a sine a is radius of sphere. A sine phi sine theta j plus a cos phi k by d theta cross a sine phi cos theta I plus a sine phi sine theta j plus a cos phi k by d phi. Okay, if someone settle it down, it becomes a sine phi minus sine theta I plus a sine phi cos theta j 0. Cross product with a cos theta a cos phi cos theta I plus a cos phi sin theta j plus a minus sin phi k. If someone cross it and calculate the magnitude, actually I have done it. So it comes as a square sin phi. This is what I remember. A square sin phi. Theta is gone. A square sin phi d theta d phi. If I integrate with the d phi, then it becomes a square minus cos phi. A square I can keep outside minus cos phi. 0 to pi. So pi minus cos phi is minus 1. So it becomes 2. So it is full sphere we are calculating now because phi we are taking 0 to pi full. Okay, in that sense, it becomes 2. It becomes 2a square. Now theta integration is d theta integration is theta 0 to 2 pi, 2 pi. 2 pi into 2a square is the surface area of the sphere. That is 4 pi a square. Okay, this way we can calculate the velocity vector in polar coordinate system, in spherical coordinate system. Means dp by d theta cross dp by d phi. Earlier it was dp by dx cross dp by dy. This was the velocity vector. Calculate the magnitude and integrate with dx dy, you get the displacement surface area. Here dp by d theta cross dp by d phi. Calculate the magnitude and d theta d phi and you get the net surface area. We will talk more on it and we will see because vector is non-ending technology. It's the it's more we do calculus in vector, more someone would be clear in artificial intelligence and machine learning because there calculus is not normal calculus. It is vector calculus, vector algebraic calculus. So we will proceed on it. Please do support us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.